Some of Earth's biggest rivers never touch the ground. They flow far above your head, invisible, silent, carrying more water than almost any river you could name. Scientists call them atmospheric rivers, and once you understand what they are, you will never look at a rainy sky the same way again. An atmospheric river is a long, narrow stream of water vapor carried by winds high in the atmosphere. Picture a ribbon of moisture stretched across the sky, sometimes thousands of kilometers long, drifting over oceans and continents like a conveyor belt made of air instead of water. You cannot see it the way you see a blue river winding across a map. There is no channel, no banks, no glint of sunlight on a surface. It is just air, thick with vapor, that used to be ocean. But satellites can track them, watching plumes of moisture stream across the globe in patterns as recognizable as any river system on land. The vapor stays invisible until it meets resistance. When an atmospheric river runs into mountains or slides into colder air, the vapor is forced to cool, and it turns into rain or snow, often heavy, often fast. This is the moment the sky river reveals itself, dumping the water it has carried for days in a matter of hours. In many regions, this delivery is not a curiosity, it is survival. Atmospheric rivers refill reservoirs that cities depend on. They build the snowpack that feeds rivers all summer long, long after the storm has passed. In some places, they deliver a large share of the entire year's water supply in just a handful of events. Without them, wells run dry and farmland cracks. But the same system that ends a drought can also break a city. When an atmospheric river stalls, or arrives stronger than expected, the water it releases becomes a threat instead of a gift. Floods rise, hillsides give way to landslides, and what should have been ordinary rain becomes a dangerous storm. The sky does not distinguish between rescue and disaster. It simply delivers the water it is carrying, and the outcome depends on how much falls and where. What makes atmospheric rivers so strange to think about is the scale of what is moving invisibly above us. An ordinary river carries liquid water, confined to a channel carved into the earth. An atmospheric river carries water too, but as vapor, unconfined, moving through open air, with no banks to hold it and no gravity pulling it downward until conditions force it to fall. It is a river with no bed, no shape you could point to, and yet it can carry as much water as some of the largest rivers on the surface below. These sky rivers are not isolated events. They are part of Earth's larger circulation system, the vast ongoing process that shifts moisture from warm oceans toward distant land. Heat lifts water from the ocean's surface into the air. Wind gathers it into these long streams and steers it across the planet. Eventually, mountains or cold fronts pull that water back down as rain or snow, often thousands of kilometers from where it started. This means the rain falling on your street tonight might not be local at all. It could be moisture that evaporated from an ocean far away, traveled for days, riding currents of wind high above the clouds you can actually see, and only now, after that whole invisible journey, found the cold air or high ground it needed to fall. Weather, seen this way, stops looking like something that simply appears overhead. It looks more like a planetary delivery network, constantly running, constantly rerouting water from where it is abundant to where it is needed, or sometimes to where it is not wanted at all. Somewhere above you right now, water is moving. It is being lifted by heat, steered by wind, and waiting for the right mountain, the right cold front, the right moment to fall. The sky is drier than an ocean, but it still has rivers, and they are some of the most powerful, least visible forces shaping life on the ground below. Follow for more random things you may not know.